The title of the presentation is General Definitions of Information and Complexity, and it will be based on my book Theory and Practice of Contrast, Integrating Science, Art and Philosophy, and addresses three fundamental issues of information theory: the general definitions of information and complexity, the information-energy relationship, and the value of information, which are still discussed and need to be clarified. The subject of information emerged during aesthetic considerations and in particular an attempt to understand visual interactions. The result was a new definition of contrast as interaction or tension caused by the impact of common, attracting, and differentiating, repelling features of the objects under consideration. Contrast grows stronger as the number, strength of common and differentiating features held by contrasting objects increases. The definition is general and covers all kinds of contrast between any objects, including contrasts that arise between perceived objects and our mind. It proved to be also the universal law of nature and principle of being, as well as a powerful explanatory tool. What makes this definition different from existing general definitions of contrast is that contrast so far has been understood as a big difference or contradiction, and in consequence it took into account only one feature, one quality of contrasting objects. It is the opposition within the same feature, for example, small, large, or light, dark. The new definition takes into account all features of contrasting objects, all common and differentiating features, and thus takes into account the diversity and complexity of objects. Contrast understood in this way is linked to other fundamental issues, e.g. the intuitive criterion of complexity, which Heidegger formulated as follows: the complexity of an object structure is greater the more elements can be distinguished in it and the more connections there are between them. If we replace connections with common features and distinguishable elements with differentiating features, we get a definition of contrast. Thus we can equate contrast with complexity. The essence of complexity and contrast is expressed by a binary model consisting of three 8-element binary structures. First, 1, 0, 0, 1, 0, 1, 1, 0. Second, 1, 0, 1, 0, 1, 0, 1, 0. And the third, 1, 0, 1, 0, 0, 0, 1, 1. Each contains 4 ones and 4 zeros, but with different arrangement, which implies a different number of substructures or information that can be extracted in them. In the first structure, 8, in the second 1, and in the third 3. Each of these substructures contained common and differentiating features which create contrast. For example, in the first structure, substructure double elements, double zeros and double ones, create a contrast where the common feature is doubleness, while the differentiating feature is value of 1 or 0. This simple model provides important conclusions. 1. Among structures with the same number of elements, the most complex, creating the greatest contrast, is the one that has the greatest number of distinguishable substructures, according to the definition of contrast and complexity. Second, in a more complex structure, the same amount of energy, which here is represented by 4 ones, energy quanta, is needed to obtain more information. The perception of a complex structure is therefore more economical, cost-effective, and thus preferred. This is also where our aesthetic preferences and beauty come from. An example is the golden division, which has more features, information, than any other division, and the additional feature is the well-known golden proportion. Third, the energy-information relationship and the value of information is explained here. The model shows that more complex, organized, and therefore more valuable information requires less perceptive energy. This kind of organization can be defined as information compression because it saves energy. In the abstract complexity definition I formulated in 2011, information compression, defined as the degree of organization, is one factor of complexity and expressed by the number of substructures divided by the number of elements, zeros and ones. The another factor is the size of compressed area, because it is more difficult to compress larger area, expressed by the number of substructures n. So abstract complexity definition defines complexity C as a number of substructures n to the power of 2 divided by the number of zeros and ones n. This formula directly refers to the binary structure and can be applied to any domain that can be formalized in digital form, e.g. music. It also allows to understand the essence of complexity and information compression in the most general abstract sense, and therefore apply to any structure of reality in the sense that it helps to find the way of information compression and complexity in any particular area. This makes it possible to pursue complexity more consciously. An example could be any text where we try to be more concise. I would like to point out here that information compression is common wherever development in the broad sense of the term takes place. We deal with it during perception, learning, cognition and creativity. It also is the objective cause of contrast, interaction, complexity, development, our preferences, pleasure, beauty, value and goodness. The above understanding of information as each distinguishable structure, which is a form of energy, is structural and general and can be applied to all areas of reality. The exception is the technical application of information, e.g. in telecommunication or computer science, where each information must be distinguished and identified unambiguously to avoid confusion in processing. Therefore, Shannon's information is not related to a system, but to a state of a set, which is a combination of equally distinct elements. Thus, we are not dealing here with complex system structures of coherently connected elements, but with collections which can also be classified as structure, but with poor coherence. Shannon's information is therefore a special case of structural information, and in fact limited to narrow technical area. Nevertheless, it is widely used beyond the technical context as a general and universal definition, together with associated algorithmic definition of complexity. Many misunderstandings arise from this. An example could be the algorithmic complexity, a shortest description length, applied to the concept called low complexity art by well-known computer scientist Jürgen Schmidhuber, where he concludes that the aesthetic attractiveness of objects, e.g. Leonardo da Vinci artworks, is inversely proportional to their complexity. From our considerations, it appears exactly the opposite. The greater contrast, value, art and beauty is where complexity is greater. That is where receiving information we save more energy. I could provide example of such misunderstanding, much more, which could be also found in my book. For now, I will concise to this one. Thank you for your attention.